Hi friends, in this session we will study about the mean deviation. Look at in this figure, you see there are so many circles x1, x2, x3, x4, x5, x6, x7, x8, xr, xr plus 1, xn minus 1, xn. So this is our data, this is our distribution and statistical data we assume. Here you see there are three polygons here. One is green, which is the pentagon. So it is Z is written in that. Z is for mod. And this one is hexagon in red color. There is X bar, it is mean. And there is a yellow square where it is M in it. So it is median. So look at this. There are thin lines of different colors with associate to the polygons, to the circle. So you see there are red thin lines X bar and up to X1, X1 to X bar, X2 to X bar, X3 to X bar, and so on, Xn to X bar. So this is the deviation of the term from the mean, X1 minus X bar, X2 minus X bar, X3 minus X bar. So you look at this here on number line. If we see, we have to take the positive because we are taking this deviation as a distance of the term from the mean. So we take always positive sign, we take the absolute value of this deviation. Okay, so now I write here for mean. If you see for median, you see there yellow thin lines are there with each term, x1 to m, x2 to m, x3 to m, and so on, xn to n. Here you see green thin lines are there with associated to z, x1 to z, x2 to z, x3 to z, and so on up to xn to z. So here I write first for mean. So you see here we take the deviation from x1 to x bar. Just a moment. It's okay. X1 to x bar. Take it. We have to take the positive absolute value, so we put here sign of absolute. So another x2 minus x bar, x2 minus x bar, then x3 minus x bar, mod of x3 minus x bar, and finally we get xn minus x bar. So get all the deviations. There are n terms in this data, so the total number of deviations are also n. The total number of deviation is also n. So now we get the summation of this all. Summation of x minus x bar. Okay, here I am putting here r. So r is equal to 1 up to n. It will r will start with 1, x1 minus x bar, x2 minus x bar, x3 minus x bar, and up to n it will go. So this is the summation of all the absolute deviation from mean. Now this is the deviation from assumed mean, and we have to find out the mean deviation. If we divide this sum of deviation from the total number of deviation, we get the mean of deviation. So we get here, if you have to find out the mean of deviation, so you have a formula, delta x bar is equal to summation of x minus x bar over n. N is the total number of terms or the total number of deviations. So this we have got here. Now we see another deviation. another mean deviation. This is the mean deviation of mean. Oh, sorry, mean of deviation it is. So now we take another one. You see, from median we take here x1 minus m deviation of, then x2 minus m mod of x3 minus m, and so on. We get here xn minus m, and we get the summation of this all the same way. R is equal to 1 up to n mod xr minus m. So if you have to find out the mean deviation through median, so we get here delta m is equal to summation of x minus m over n. So this we have got here. Now we see the third one. Which is green, the deviation from mode. So we write x1 minus z, here x2 minus z, here x3 minus z, and so on up to xn. So xn minus z. Here you see, if you take the summation of this all, summation r is equal to 1 up to n xr minus j. So if you have to find out the mean deviation through mode, we get here delta z is equal to summation of x minus z over n. So this is a way, this is the concept behind the mean deviation. We have defined what is mean deviation basically is. Now I would like to tell you the direct method how to find the mean deviation through this formula. First you look at this direct method formulae for individual series or raw data. So here mean deviation through mean, we have derived this formula above. Delta x bar is equal to summation of x minus x bar over n. Here you see mean deviation through median, delta m is equal to summation of absolute value of x minus n, okay, over n. The mean deviation through mode is delta z is equal to summation of mod of x minus z over n. So these are the formulae which we use for raw data for finding out the deviation or through different center measure of center tendencies. Here you see the direct method for discrete series or group data and ungrouped data. You look at this mean deviation through mean. If you have to find delta x bar is equal to summation of f into absolute value of x minus x bar over summation of f. Similarly, mean deviation through median, you see delta m is equal to summation of f into mod of x minus m over summation of f. And finally, mean deviation through mode, delta z is equal to summation of f into mod of x minus z over summation of f. So in this way we could easily find out the mean deviation of various measure of center tendency with direct method. Now I would like to tell you that these both are the absolute measure of mean deviation. Now look at the relative measure of mean deviation, which is the coefficient of mean deviation. So through mean, if you have to find out the coefficient of mean deviation, then it is equal to delta x bar over x bar. We have to divide, if you have to find out the coefficient of any mean deviation, then we have to put the mean deviation in numerator and divide it by the corresponding their mean, whatever the average. So through median, if you have to find out, is equal to delta m over m, and the through mode is equal to delta z over z. So in this way we could easily find out the coefficient of mean deviation, which is a relative measure of deviation. Now we look one example. here you see we have taken one example individual series or raw data is here. The data is given income per day in rupees. They have given the income 30, 40, 42, 44, 46, 48 and 58. So these they have given to us. So for this, first of all you look at this here. First I would like to explain the formula. The first formula is for mean, because we had to find out the deviation through mean. We are getting out the mean deviation through mean. So here you see x bar is equal to summation of x over n. So first of all we have to find out the mean. After getting the mean, we have to find out the mean deviation and the absolute value of that mean deviation. So formula for mean deviation through mean is delta x bar is equal to summation of x minus x bar over n. We have to apply here. So what we do, first we find out the mean. So I write down mean. Here first I write down this data. I write down this data here. So x is given to us from 30. It is started. So it is 30. Just a moment. It is 30, then 40, then 42, then 44, 46, 48 and 58. These we have data, and we get the summation of this, summation of x here. For getting out the mean, the summation of x is required. So we get the summation of this. It is look at this, 2 plus 4 6, 6 12 and at 20 it is 28. So 2 carry 2 3 5 or 4 9 or 4 13 or 4 17 and 4 21 and 4 25 and 5 30. So it is 308 we have got here. So now we find x bar is equal to, the summation of x is 308 and the total number of terms, we look at this, 1 2 3 4 5 6 7 terms we have. So x bar is equal to 74 times 28, 74 times 28. So we have got here the mean which is required for the calculation. Now we have to find out the x minus x bar. So what we have to do here, I explain you. I put down here x is 30 minus 44. 44 is the mean. We have to find out the deviation from means. We get minus 40. Now here you see it is 40 minus 44. It is minus 4. It is 42 minus 44. It is minus 2. It is 44 minus 44, which is 0. If we get 46 minus 44, we get positive 2. 48 minus 44, we get here 4 positive, and 58 minus 44, we get here positive 14. Basically, if you find out the summation of the deviation from if you get the summation of mean deviation from mean and add it up, so you always get 0. So therefore we have need of absolute value of this, because we are counting as it is a distance of a number with mean. So we get here 14. Positive number is 14. It is 4 now. It is 2 0 2 4 14. So it is 20 plus 20. It is equal to 40. So we have got 40 as the summation of absolute value of x minus x bar. Now we put here So delta x bar is equal to summation of x minus x bar is 40, and it is divided by total number of data, which is 7. So we get here 7 5 times 35, 5 remains 7 7 times 49, and 1 remains 7 1 times 7. So 5.71 is there. This is our mean deviation through mean. So it's very easy to calculate, pretty easy to calculate this mean deviation through mean. Now we see the same example we apply for the deviation from median. Now we find out the mean deviation through median. Look at this, the same data we are taking here, 30, 40, 42, 44, 46, 48 and 58. For this the formula we are using, the first we have to find out the median. The formula for median is the total number of terms. I would like to tell you that here which are, this is the first term, this is the second term, this is the third term, this is the fourth term, fifth, sixth and seventh. We have the 7 terms total. So the n is equal to 7. We have n is equal to 7. So the total number of terms are odd. If the total number of terms are odd, we use this formula. Median is equal to value of n plus 1 by second term. So first of all we have to find out the median. So we get the median here. So median is equal to value of 7 plus 1 by second term. So why we have taken here 7? Because the total number of terms are 7. So now the median is equal to value of 7 plus 1, 8 over 2 is 4 term. So value of 4 term, look at in the table. The value of 4 term is 44. So the median is 44 here. So we have got the median here. So this is our median. We have got here the median is the same as mean we have got, because it is the normal distribution basically in this data. So if we take the deviation from median, it would be the same as in the mean, because the median and mean both are same. So we get the same mean deviation 5.71. okay. So the mean deviation we get here also, so through mean deviation through median we get here which is summation of x minus summation of mod of x minus m is 40 here also, and we have to divide it by 7. So we get here 5.71. the similar thing we will get. Now I would like to tell you one thing more regarding this. We have not found out the coefficient of mean deviation previously through mean. So we find out the mean deviation through median here. So mean deviation through median and mean deviation through mean. So look at this, the mean deviation through median coefficient of mean deviation through mean, through median. We get here, we know the formula that delta m over m. So I put down the value here. You see the delta m we have 5.71 over m is 44. So we get the same mean coefficient of mean deviation as for our mean also. So it is 5.71 divided by 44. So we get here 0.129. 0.12977. So this is our coefficient of mean deviation through median. The mean it would be same. Now you see here we have last one, the mean deviation through mod. So in the raw data it is not possible to find out the mod. Mod is the value of the highest frequency. The frequency of the each data is 1 here. There is no data is repeated here. So we see how we get the mod. So we get the empirical mod here. So we have the formula for empirical mod, 3 median minus 2 mean. So I would like to explain this. We find it out first. So Z is equal to 3. Median we have got 44 minus mean. 2 times of mean. Mean is also 44 we have. So we take 44 common. It is 3 minus 2 is 1. So we get mod is 44. It is also same as mean and median. So the data would be same. If we take the deviation from mod, we get the same value 5.71, and the coefficient of mean deviation through mod, we get the same value as we are looking at here. The same value we get here, the 0.12977 for all. So this is the way how to find out the mean deviation of a raw data through the different measure of central tendency. In this session we have seen that how to find what is the mean deviation through how we get the mean deviation through various measure of central tendency of raw data and discrete series, individual and discrete series both. Now we see what are the merits and limitations and the usefulness of mean deviation. So first I would like to tell you, here we see first the merits. It is easy to understand. I have explained, you have got this thing, that easy to calculate. It is very easy to calculate. No major calculations are there based on all observations, because all observations we include here. Then the deviation can be calculated from any of the averages, because we can calculate by mean, median or mode. It is a representative of the data, because all the central tendencies are representatives of data, so it is also representative of data. Not unduly affected by extreme values in the data. If the extreme values are changed, so it does not affect. Okay, so it is calculated by omitting. Now that we see the limitations here, it is calculated by omitting algebraic signs. We use always absolute value, the mod of the value. We use the positive sign. We don't use the negative sign. So the values this is the omitting, this is the limitations. The values of the mean deviation are differ when it is calculated by measure value of the central tendency. In the data we have taken an example, it was the normal distribution. So we got all the values are same, the mean, median, mod. Basically the mean, median, mod does not come same in the skewed data. So we get all the deviation, different deviation we get there. So not capable in further algebraic treatment. We could not use this in the further algebraic treatment, because we are changing the sign. Now the last thing we have to find out the usefulness of this. It is especially effective in reports represented to the general public or to groups not familiar with the statistical methods. So we could use this thing. The public who are not familiar with the statistical method, we could use this method. The measure is useful for small samples. It is not for very large samples. We could not use it with no elaborate analysis required. There is no elaborate analysis required. Just we had to give the deviation. It is the deviation there. So we could use this thing. The National Bureau of Economic Research is for forecasting of their business trends. So this way, in this session, we have said lots of about mean deviation. Thank you for